So this question that we are going to solve is diameter of a binary tree. So but what exactly is a binary tree? A binary tree is a tree in which every node has at most 2 children. So and diameter is the length of the longest path between any two nodes in a tree. So if you start from one node, the longest you can go to a different node, that would be the diameter of a tree, and it might or it might not pass through might or might not pass through the root of the tree. So let's see, for example, here. So if you have this tree, right? So currently here, if you see, the longest path would be this, okay, going from 4 to 1 and 3, 4 to 1 and 3. Coincidentally, this passes through the root here, but that's not like we can't guarantee that. Let's imagine we have like a couple of children here below 5, like we have one here, like, and then we have 6, 7, 8, 9 till 100, let's say, and then the longest path would be, and then in the 4 also we have like 200 children, like 5, 600, 9, 10, and then so the longest path would be starting from here, going to 5 and going to 2 and 4, and if you see that it's not passing through the root at all. So yeah, but it might not pass through the root, but it would like for sure pass through some node. There will be one top level node, and then it will like go like this, and like it'll stop at one node, and then from there it'll start its descent. It'd be something like that. So we can go to each and every node, and then we can see the longest path we can get on the left side, and then longest path we can get on the right side, and we can see if their sum is like the max. We can compare that, so that we can try that. See, so let's have an answer. So on the longest path, so let me put the answer as like negative infinity. Okay, and then let's have a recursion. Okay, I'll name this letter root illustrate node. So what this would do is this would return the longest, like it would return the longest path from that till the end of the tree, one side, so that when we go to its parent, we can like see the longest on the left and the longest on the right. So we can do that. So if node is none, then there's nothing there, so just return 0. Else we'll get the left max part as recursion of node dot left. Oh my god, left. And then right max would be recursion of node dot right. And then so we have the leftmost part and the rightmost part. So the path that goes through this node would be the left plus right plus 1, because we have to even add the node itself. So we'll compare it with the answer. So self dot answer is equals to max of self dot answer comma left max plus right max plus 1. But we have to return this is fine. Now we have a path, but then we have to return something to the parent so that it can compare something to. So that would be the longest path, longest, like single longest path, like it's not like a V shape, it's like a straight longest path that goes through this node, so that this can be compared, this can be added to the rightmost part of the parent and compared to the answer. So we have to return like either 1 plus max of left max comma right max. So either the singular path would be, not singular, the linear path I'm talking about. So the linear path would be the left linear path or the right linear path plus the node itself. So yeah, and then we return we have to run this recursion on Then on the root I have to return this self.answer. Is it working? Our answer is like off by 1. What if I do -1? Would this work? But why should we do that? Let's think. Okay, left max would be this left max, right max, this right max plus 1. And then while returning, you have to return like max of left max, right max plus 1 to its parent. Where are we going wrong? Okay, let's see. Let's look at the easier thing. This is the easiest one. We'll see why it's. Just remove this also. Just put one node. So this node is like this. Oh my god, what's this? So okay, there's only one. What's that? Why should we return 0? But in any two nodes in a tree, this path may or may not pass through. Okay, so there's only one element. I thought the path would be 1 because this is still a path, but they're saying that the path should be between any two nodes in the tree. Okay, so what exactly is path? This path, okay, it's the edge between them. So if there are two nodes, there will be only one path. Okay, and here we are counting nodes, so we have to return path. So if there are n nodes, we'll have n-1 path. Like we'll see here, 1 2 3. We have 3 nodes, but the path will be only 2. And here we are like calculating the nodes, number of nodes. That's the reason we have to do -1 at the end. Guys, never do something without understanding that. Now that it's working, let me submit this. If it's working, then we have to change the name of this function, because recursion is pretty bad. Okay, so it's working. So the name of this function would be longest path to a leaf. I think that would be a good name. Or I'll just write longest path from that point, from the node till the end. Yeah. Or we have to name something bad. I'm really bad at naming things. Okay, so yeah, that's it. Bye.